Today's lesson, the last section in chapter 1, is we're going to find some pretty useful quantities that are review quantities. In particular, perimeter, area, and circumference. Circumference being specific to circles. Hopefully the answer to the warm-up were on the front here. Make sure you had those copied down at some point. We're going to look at and review some of these formulas that you should have seen in the past and we'll bring back to the forefront of your brains here. We're going to look at the perimeter for each of these four very basic shapes. The perimeter being symbolized by P. The formula for the perimeter. Well, we better know what perimeter is. What does perimeter represent? What geometrically does that represent, Helen?
Like the outside of the shape.
The outside length of a shape. So we're going to describe in this formulas how to figure out how long it takes to go, how much distance it takes to go from one vertex all the way around back to it on our polygon. For a square, well, if you know the side length, we'll just go 4 times whatever the length of a side is of a square. So the square has all 4 sides the same length. Pretty simple. 4 multiply whatever the side length is by 4. For a rectangle, rectangles have 4 sides, but they have 2 pairs of the same sides, called the length and the width. Perimeter of a rectangle, and remember that? Twice the length plus twice of the width. Since these two are the same, just add them up twice. A triangle, triangles don't really have a nice, in general, don't have a great relationship. So we'll say it's side 1 plus side 2 plus side 3. We'll just add all the side lengths together. It's nothing fancy. Add whatever the 3 sides are. And a circle, the perimeter of a circle is a special name. The circumference. So it's actually the same as the circumference symbolized by C. And the circumference of a circle. Do we remember this from back in the day? Are we ready?
Pi r squared.
Oh, that's our other formula for a circle. What's the perimeter formula, Greg? Pi r? No, not quite.
2 pi r?
2 pi r. R being the radius or the distance from the center to the edge of a circle. And Eunice, you know what's the other formula? You can also rewrite this formula since the radius is from the middle out. You can rewrite this as saying, well, the diameter is just twice the radius because it goes from edge to edge through the center. 2 pi r is the same as pi times the diameter. Well, let's go back to the beginning. What's the area formula for a square? S squared. Whatever the side is times itself. The area formula for a square is S squared. Pretty simple. How about for a rectangle? Dimitri?
Length times width.
Just length times the width. This is the one that people always tend to forget coming from back then. Kate, what's the area formula for a triangle?
It starts with half.
Yep, starts with a half.
Is it half base times height? That's
Half of its base times its height. The height of a triangle is described as the distance from a vertex down to the opposite side at a right angle is the height. The base being that opposite side. And what's pretty cool is that you can actually choose any base, any side of a triangle to be the base, and then just figure out if you know what the height is. You can find the area. Pretty cool. And then area, Helen, what's the area formula?
Pi r squared.
Pi r squared. Absolutely. Everything else will be based on this. So if I want to find the perimeter of this rectangle, well, let's see. This is a rectangle, so the perimeter is just twice the length plus twice the width. So this is our length, and that's our width. Then the perimeter is just twice times 12 plus twice times 9. Twice of 12 is what, 24? plus 18, which is 42, and our unit is feet. Will be the perimeter. Similarly, the area, straight from the formula, is just the length times the width, which is 12 times 9, which is 108. And what's the unit that goes with area? Feet squared. Find the circumference and area of the circle. Circumference being two formulas, either 2 pi r or pi times the diameter. 18 is described here as the diameter. 18 is the diameter. It goes all the way across. If 18 is the diameter, what's the radius?
9.
R is 9. So combining the radius being 9 and the diameter being d, you should be able to find both of those quantities. Okay? Pick whatever circumference formula you like better. Use the appropriate length, and you'll get what we're looking for. So if we go pi times d, that's 18. Pi would be our exact answer because we haven't rounded. Or approximately, what's 18 times pi?
56.54.
5.
We'll go to the hundreds place this time.
It's 5.
How are we debating this?
It's 56.5.
I don't know.
Similar game. Area should then be what? Pi times 9 squared, which is 81 pi, which is approximately 81 times pi was what?
254.47.
Inches squared. Okay. Triangle ABC has the following vertices. Triangle ABC has the following vertices. A is at 2, 5. So over 2, up 5, 1, 2, 3, 4, 5. B is at 4, 1, 1, 2, 3, 4, up 1. C is at 8, 3, 1, 2, 3, 4, 5, 6, 7, 8, 3. And it makes this triangle. What is the perimeter of this triangle? How in the heck are you going to find the perimeter of that triangle? Oh, you're going to have to find the distance of all three sides using the distance formula since you have points. Length of AB, length of BC, length of AC. Holy cow, you're going to have to use the distance formula not once, not twice, but 3 whole times you have to use the distance formula. For this example, right now, divvy up the work between your table groups. So one person take charge of each of the problems. If you have 4 or more, then split the work.
No, I said I was not.
AB, if you did this correctly, is the square root of 20, which is approximately what? 4.5. BC is also is the square root of 20, which is approximately 4.5. And AC is equal to square root of 40, which is approximately what?
6.32.
6.32, rounding to the 10th place, 6.3. So then if we know that these are the side lengths, what is the perimeter of this triangle? Add them together. What's your answer? 10.8 plus 4.5 is 15.3.
15.3 inches and 8.
There's no unit that goes along with it in the problem, so we don't have to worry about a unit in our final answer. This young lady can mow 600 square feet of grass in 10 minutes. How long will this lady take to mow her lawn that is rectangular and is 60 feet wide by 80 feet long? Well, I'm looking for a time here. And if I tell you this, then you know it's speed. So what's a formula that relates speed and time to something else? What's your favorite formula from back in the day? Distance equals rate times time. Well, it can also work in we can adjust this formula to be, well, if we know the area that's being mowed, we know a speed or a rate, that we can mow a rate or a chunk of the area times how long you go. We can work in the same formula. The same thing applies. Okay? So if we can know how big the yard is, we know how fast we can mow, then we should be able to come up with how long it'll take. Is the general game plan here. So how big is this lawn that we're trying to mow?
4,800.
60 times 80 would be 4,800 square feet is the area. What's the speed at which she mows? How are we going to find the speed at which she mows?
Well, if you want to do it by minute, you would go 600 square feet divided by 10.
So the speed could be, she can mow 600 square feet in 10 minutes. So she can mow 600 square feet in 10 minutes. How much does she mow in 1 minute? Divide this by 10 and you get 60 square feet per minute. So if you know the area that she's going to mow, you know the speed at which she can mow an area, then we should be able to find the time. Or you could say 4,800 should equal 60 times the amount of time. Divide both sides by 60, and you end up with time is 80 minutes. The area form of a triangle, we could say that 42 centimeters equal to half of 14 times the height. And don't look now, but this equation is very similar to one of the warm-up problems that we did. So the algebra involved should be the same algebra. Okay? The same skills you use for this one, you used in the warm-up. Okay? You can finish solving this using those, and you should end up with a height that is 6 centimeters. You use that same algebra we did in the warm-up. Okay? And check your answer yourself.